Hi everyone, this is section 4.6 from our Hawks College Algebra textbook, and we're going to talk about the inverses of functions today. So when I think of inverse, I kind of think of opposite or reverse. So if a function is a one-to-one function, then we can find an inverse for that function. And the way that we're going to do that, and we'll go through these steps as we do this with equations in the future, but you take f of x and replace it with y. So you make it a y equals equation. And then what you do is inverse means you invert x and y. So you switch all the x's and y's in the equation. So where there's a y, you put x. Where there's an x, you put a y. Then you take your new equation, solve it for y, so make it y equals again, and that is your inverse. And what you would do at the end is replace the f of x with f of -1 of x. Now, one word of caution. F of -1 is a notation to denote that it's an inverse, not that you should flip it and make it 1 over f for the exponent. It's not a negative exponent. It's just a notation that we use to indicate that it is an inverse, not a negative exponent. So earlier in another section, we used the vertical line test to determine if our function or if our relation was actually a function. If it passed the vertical line test, so our vertical line, remember, goes up and down, then we knew that our relation was a function. Now, in order to see if your inverse of your function is a function as well, instead of doing the vertical line test, you're going to do the opposite, and you're going to do a horizontal line test. So if you take your function that you have and you run a horizontal line over it, as it goes from left to right, it should only touch the graph at one point in order for the inverse of that function to actually be considered a function or meet the criteria for a function. One-to-one functions means that every pair of distinct elements in the domain is paired with exactly one. So basically one element of the domain is paired with one element from the range, and they're all different. So before we may have had two different domains like 1 and 2, and they both go to the same range of 3. But our function would not be one-to-one if that is the case. Instead, we would have to have like 1 and 2 be our domain. So 1 and 2 is our domain, and the range would be 3 and 4. So they have to have different ranges, different domains in order for your function to be one-to-one. Okay, so here we're going to look at our first relation, and then we're going to determine the inverse of the relation. So for A, our relation is a set of ordered pairs. And remember, the inverse, that's your x and your y values. Your inverse, you simply swap the x and the y values. So that means for the inverse of r, or r to the -1, remember that's our inverse notation, would be the ordered pairs, and it would be -1, 4, 2, -3, and then 5, 0. Okay, the domain, we're not going to worry about graphing the ordered pairs. You guys can do that. But the domain and the range. The domain for the first relation, or the original relation, was 4, -3, 0. And my range was -1, 2, and 5. But if you look down here, my domain in my inverse is -1, 2, and 5. And my range is 4, -3, and 0. So the opposite there. All right, for B, what we're going to do is we are going to, again, for your inverse. The inverse relation is the set of ordered pairs which the coordinates are interchanged, so we can, and basically what you're going to do is for your inverse here, we're going to switch x and y. So we are going to have x equals y squared. We switched our x and our y, and that is going to be our inverse. The domain for the first one, as we know, it's a parabola. So your domain would be all real numbers, but your range, because remember, your parabola, if it's x squared, would start at 0. So our range would be 0 to positive infinity. And that's our range for the first one. Now, for the second one, if you were to graph x equals y squared, it is going to actually look like this. Sorry, it's not a beautiful graph. But in this case, really think, we switch the x and the y values. So the domain for the second one, or for the inverse, which is right here, our inverse, your domain, your x values are going to be 0 to positive infinity. Oh my gosh, that's horrible looking. Let me scratch that out. Let's see here. Let's see if I can do it better. 0 to positive infinity. That's your domain. And your range, it's going to be anywhere on the y-axis, so it's going to be all real numbers. Now, they're not always as easy as this. This one was kind of nice and easy, but they're not always that easy. Okay, so here they are asking us, determine if the following functions have inverse functions. So if we sketch f of x equals the absolute value of x, if you recall, the shape of that graph, if I were to draw my x and y axis, is a V shape, so it looks roughly like this. All right, so in order for our function, which this passes the vertical line test, in order for it to be a function or have an inverse that is also a function, it would have to pass the horizontal line test. So if I do this and I draw, I'm just going to draw a horizontal line so you can see it. All right, if I draw my horizontal line in there, notice it's touching more than one part of the graph at one time. So there is no inverse function for the function f of x equals the absolute value of x. You may be able to find an inverse to the equation or the relation, but it is not a function because it does not pass the horizontal line test. Okay, so our second one is our cubed graph, which I'm going to try to sketch it. And again, it may not be perfect. Don't judge me. It's okay if you do, though, because I can't draw. But it's x plus 2. So remember, that's going to shift the graph. It's adding to the x. So it's actually going to shift it to the left 2 places. So our graph is going to look somewhat, again, we know this is not going to be fabulous, somewhat like this. It's not going to be as flat right here as it is, but it shouldn't be that flat. Now, if I were to look at this though, and I do my horizontal line test, when I do the horizontal line test, if I draw, and again, I'm drawing the lines so you can see them, but as I go across, and ignore like that, it shouldn't be that flat there, but as I use my horizontal lines, this graph does pass both the vertical and the horizontal line test. So that does mean that while yes, it is a function, it also means that the function, the inverse of that function, is also considered a function. So the inverse is also a function. And we're going to look at, in the next couple slides, how to find the inverse of a function, something like this or similar to this. Okay, so now what we're actually going to do is we are going to not look at our function on a graph and figure out if it has an inverse, but we're actually going to find the inverse. So they are going to ask us to find the inverse of each function. So remember, in a previous slide, we looked at the slide, and the first thing it says is replace f of x with your y equals. So I'm going to make this equation, instead of f of x equals, I'm going to make it y equals, and then we're just going to leave our x minus 1 cubed plus 2. Step 2 says switch your x and your y values. So step 2 is going to be x equals, and then in parentheses we'll have y minus 1 cubed plus 2. Step 3 was they want you to solve the equation for y. So now we got to make it y equals like it was up here. So what I'm going to do to solve this, because we have that cubed root there, first thing I'm going to do to solve for y is I'm going to subtract 2 from both sides. So I'm going to have x minus 2 equals y minus 1 cubed. And then I really need to get rid of my cubed root. So remember, the way to get rid of a cube is to, or my cubed exponent is to take the cubed root of both sides. So we'll do that. And that's going to leave me with the cubed root of x minus 2 is equal to y minus 1. And we got to solve for y, so I really need to get rid of that minus 1. So I'm going to add 1 to both sides. And that is going to give me a final answer of y is equal to, and then we're going to have the cubed root of x minus 2 plus 1. Now, the final thing you want to do is replace your y with your function notation. So to show that it is the inverse of a function, I'll do f of negative 1 of x equals the cubed root of x minus 2 plus 1. And that plus 1, because it's outside the radical over here, is going to be outside the radical in your final answer. All right, let's take a look at the last one. We're going to find the inverse of g of x equals x minus 3 over 2x plus 1. So first thing we're going to do, again, is replace the y, the g of x with y. So I'm going to make it, y equals x minus 3 over 2x plus 1. And then we're going to switch x and y. So now it's going to be x is equal to y minus 3 over 2y plus 1. And now what we have to do is we have to solve, excuse me, we have to solve for y. This one's a little like involved because we have y on the top and the bottom there of our fraction. So really, I know you guys don't like fractions. The first thing you want to do, get rid of that fraction. So what we're going to do to get rid of it is I'm going to multiply both sides by 2y plus 1. So by my common denominator. All right, so that is going to give me 2y plus 1 times x is equal to, and then over here on this side, remember they cancel out, so it's equal to y minus 3. Okay. And now what we're going to do is I want to move, I want to distribute first my x. Let's do this. Let's distribute our x so that we can move around some stuff. So I'm going to make it 2xy plus x, excuse me, is equal to y minus 3. And then what we're going to do is we're going to move both y terms to one side and the x term to the other. So let's start by subtracting x from both sides. And when I do that, I'm going to end up with 2xy is equal to y minus 3 minus x. And then I'm going to subtract y from both sides so I can get the y's on one side. So I'll have 2xy minus y, and they're not like terms, so I can't combine them. equals negative 3 minus x, or negative x minus 3. Order doesn't matter. Okay, so we still have to solve for y. So now it's in both terms here, but they're not like terms, so I can't combine them. But I can factor, and that would be my GCF. So I'm going to factor out my y. I'm going to make it y times 2x minus 1, because notice if I pull a y out of both of those, equals negative 3 minus x. And now to get y by itself, it's y times 2x minus 1. So I'm going to divide both sides by 2x minus 1. And when I do that, it's going to give me y is equal to negative 3 minus x over 2x minus 1. Or, if I make it an inverse function, we'll do g of negative 1 of x is equal to negative 3 minus x over 2x minus 1. And that would be the inverse of our second function here.